Hello everyone, welcome back again. This is the second part of our two-way ANOVA. Remember when I was explaining the concepts, one of the assumptions is that the continuous dependent variable must be normally distributed. So let's check the normality of this one before we start the actual running. So to check whether this data is normally distributed, we go to Analyze, then we check Descriptive Statistics, select Explore. So in the Explore, you put the academic score in the dependent list. That is all you have to do for here. And then you come to the plot, and then you say normality plot with thesis. Then you say OK, then we display. So now these are the various theses. When we use the Shapiro-Wilk, we say the p-value must be greater than 0.05, and then this is what you use. And then if you use both this one and that one, you realize that their significant values are always greater than the 0.05, which means that the data set is normally distributed. And then we have some distributed tests, plots. But usually I prefer using this one, histogram. So let's just go and then add a histogram. Explore. And then plots. So let me select my histogram so that we can see it clearly. Now this is our histogram showing the normality. So you realize that this side is approximately the same as the other side. And majority of the distributions are in the center. So let's put the curve and then see how it looks. Then you right click and then right click on it and then show distribution curve. You realize that our distribution is normally distributed. So this assumption is being satisfied. So now let's go with our normal business. So this one will include it. We'll include this in our report. So we are now going to do the two-way ANOVA. So we go to Analyze. We check Generalized Linear Model. Because we have only one dependent continuous variable, then we choose univariate. Then when we come here, the dependent, the continuous one, we put it in the dependent variable. So we have it here, and then these two, we put them into fixed factors. Then we come here, is very important, the model, and then we make sure that the full factorial is selected. This one is selected because it tests all the possible effects. It tests all the possible effects, that is the main effect and the interaction effect. So if it is already checked, thank God, we continue. And then we come to plots, and then you can put each and every one of these in any way. So this one has more levels, so I always like putting it in the horizontal axis. And this one is only 2 levels, then I put it in separate lines. Then you say add, so that once it is here, you see the plot. Then continue. Then you come to this side, post hoc. You don't need that side. Then you continue. Then you come to options. This is very important. So you put this, and then the academic level, gender, academic level, and then these ones. That is when you check the main effects, and then the other ones, the homogeneity test. So here you have to make sure descriptive statistics is checked. Estimate of effect size is also checked, and homogeneity to check the variance. So this one is checked, the descriptive is checked to display the means and the standard deviations. This one is checked to check the effect size. If gender, what is the effect of gender? Does gender has more effect? So, or if it has more effect, does academic level has effect? Does their interaction has more effect? That is why we check this one. And this one, homogeneity or variance, we always try to check if there is differences in their variances based on the level. So we say continue, and then I think we are done, and then we just say okay. So when we run it, the first table here is just showing the frequency of each and every one of the categories, so it's not important. And then we have our descriptive statistics. So male undergraduates and then male graduates and male postgraduates, these are their various mean performances. So you realize that the undergrads performs lower than the graduates, and they also performs lower than the postgraduates with their standard deviations. When you come to the female side too, it also follows the same trend. The undergrads performs lower than the graduates. The graduates also performs lower than the postgraduates. And when you take their general, generally the graduates performs lower than the undergraduates performs lower than the graduates, and the graduates also performs lower than the postgraduates. So this one is just giving us the trend. So we take the leveling test of error. So we check whether there is differences in their variances. So over here we say the P8, this one is satisfied when p-value is greater than 0.05 and 0.204 is greater. So it means that the test of homogeneity is satisfied. It's one of the assumptions. So then we come here, test between subjects. That is where we will see whether the main effect exists and then the interaction effect exists and their effect sizes. So these two columns are very important here, the significance and partial eta square. So over here you take the male, you realize that they all have significance effect. So this the male effect, which is a main effect, the female effect, which is also a main effect, and then the interaction when we put them together. But when we check, we realize that the academic level has more effects as compared to the gender, and then also has more effects as compared to the interaction. So this one is estimated marginal. That is when we are taking each and every one of them into consideration. So, but this side is not important for me because we are not going to be doing it on individual basis. So we take each and every one. I think that side is not important. And then we also now do it based on academic level. So the important part is where I just explained. And this particular table here too is just giving you the visualization. So we take into consideration males and then females, and then we also have their trends, trends of their performance. So the female is being represented by the green and the males by the blue. You realize that generally the females perform better than the males. And when we also take the graduates, undergraduates, and then the postgraduates into consideration, you realize that the undergrads, the graduates performs better than the undergraduates, and then the postgraduates also performs better. So this is how we run it. So whenever we are doing, we will now put the assumptions, the leveling test, and then the assumption of homogeneity. So we put them into, that will come to satisfy the assumptions. So in our next video, you will see how we report the findings. Thank you for following. And please, I will leave the data in the description section so that you can download and practice. Thank you.